In this lesson on internal energy, we're going to be moving on from the changes of state lesson from last week and trying to explain this graph a little bit more. So we first looked at this graph last week when we realised that these flat horizontal lines mean that there is a change of state happening in the substance that's being heated, and that if we followed them back to the temperature axis, that we'd be able to find either the melting point or the boiling point from a graph. So let's first consider what happens if I have a beaker of water and I'm applying some heat towards it. Okay, let's just think about water to start off with. So I'm applying some heat. Let's say that we've put it on a Bunsen burner. I've got my beaker with water inside it on top of the Bunsen burner. So what's going to happen? Well, the particles are going to gain energy. Okay, overall, that's what's going to happen. Okay, so sometimes this energy will be kinetic energy. So if we think back to the energy topic that we did, P1, we should know that kinetic energy is the energy that something has when it's moving. So when the particles are moving, they have kinetic energy. So if they move faster, then we have a temperature increase. Okay, if they slow down, then the temperature will decrease. It will be the opposite. So this is the kinetic energy of the particles. If it increases, it will move faster. So let's say it increases here. So if the kinetic energy increases, they will move faster and the temperature increases. But some of you will be thinking from last lesson, well, we know that here there isn't a temperature increase, but the particles are still gaining energy. So what's happening there? And that's because we have a different store of energy called the potential energy. And when this increases, then particles move away from each other. Okay, but there's no temperature increase, and so there's no temperature increase, but it can change state. So if we go back again to our particle diagrams from the 2 lessons ago, if we've got a liquid, so we've got particles that are close together but not in any kind of order, and they're going to a gas where the particles are much further away from each other. So they're moving faster, which is from the kinetic energy increase, okay, but they are further apart from each other, and that's because their potential energy has increased when it changed state. Okay, so let's have a look at this then. If we colour code this, so we can say for kinetic energy increases, let's make that green. Okay, kinetic energy increases, so they move faster and the temperature increases. We should be able to label our graph with the places where the kinetic energy is increasing. So have a think about it first. And hopefully you've spotted, because the temperature is increasing, it's any of these bits that have a sloped line. So I'm just going to write kinetic energy here, kinetic and kinetic, because that's the energy that is at each of these points. Okay, we might also be able to spot, we've got 3 places. So at this point, it's going to be a solid. At this point, it's going to be a liquid, and at this point it's going to be our gas. So now we can think about our potential energy, so let's make that purple. Bit of alliteration. And this is where there is no temperature increase and the state is changing. So that's these two flat lines that we've got here. So we can just write potential here and potential here. Okay, and what's happening here, well, we can be a bit more specific. If it's going from a solid to a liquid, it is melting. And if it's going from a liquid to a gas, then we could say it is boiling. So there are exam questions sometimes that you get where you have to label this graph, where you have to read off the boiling point or the melting point. And there's some other things that we can do with it which we will look at in the coming lessons.